I am Dr. K. Anandan, Associate Professor and Head, Department of Physics, Amet University. Topic is magnetic effect of electric current. The magnetic field will be created by using the electric current. So that is a magnetic effect of electric current. So in this, the term magnetic effect of electric currents means the electric current when flowing in a wire, it produces the magnetic field around the current carrying conductor. Okay, so we know that there are the three different type of materials is available, that is insulator, semiconductor and conductor. In the conductor, the current flowing through the conductor, when current flowing around the conductor, the magnetic field will be created. The effect first is discovered by the Hans Christian Oersted in 1820. So you can see that images. So in the images, the battery is connected to the coil. So when the current is passing through the coil, the magnetic field will be created around the conductor. So if you are fixed the iron rod inside the coil, that temporarily the iron rod will be act as an electromagnet. That is a strong magnetic field. Okay, so when we are switched off the electric current, that will be the magnetic field will be disappear. So the electromagnet will not be there. So here, if you take the two circuit here. So in these two circuit, we are passing the current. The first one, the second one, the current direction is a different direction, in the opposite direction. Okay, if you look at the first one, we are passing the current from left to right. That is a current direction. It's indicated as a red color arrow mark. That is a current direction. While current flowing in the first circuit, the magnetic field will be created around the conductor. So, okay, so you consider, so this is a current carrying conductor. So this is the direction of the current. So the magnetic field, it is created around the current carrying conductor. Likewise, in the opposite one, it's a opposite direction. Accordingly, the magnetic field will be created. If you bring the two magnetic needle near to these two circuits, according to that, the magnetic field, what is that? If you consider that a horizontal line, the current carrying, talking about the first circuit, so the current carrying conductor, that is the current direction, the magnetic field direction, this one. So the above the horizontal line, the lines are coming out, the below the horizontal line, the lines are entering. We know what is the magnetic field direction, right? So in the magnet, so outside the magnet, the lines are coming out from the north pole to the lines are entering in the south pole, right? That is a magnetic line direction. Okay, if you consider this one, the above the horizontal line, the lines are coming out. So we can consider as a north pole. When lines are in the bottom of the horizontal line, that is a current carrying conductor, its the lines are entering. So we can consider that is as a south pole. When we are bring the magnetic needle near to the circuit, we know the opposite end will be attract, right? So here, when we are bringing the magnetic needle, so here bottom of the horizontal line, that is the south pole, and the north pole of the magnetic needle will be attracted towards the horizontal line. So from this simple experiment we can understand, so the magnetic field will be created around the current carrying conductor. So that will be opposite in the other one. So the magnetic field direction will be decided based on the current direction flowing in the conducting wire. So the next one, how we can understand, how we can remember the magnetic effect of electric current. There are two laws. The one is the corkscrew law. The second one is the right hand thumb rule. First we are going to discuss about the corkscrew law. The James Clerk Maxwell explained the direction of the magnetic field with the corkscrew law in the early 1860. Okay, so what it tells us, if you take the screw, you consider the remote is as a one screw. Okay, so that is the sharp edge of the screw, that is the bottom of the screw. Use your right hand. Okay, so take the screw, you are going to tight the screw on the wall or any material. If you tight the screw will be entering in the wall. While entering in the wall, we are using the right hand, so we are turning the screw like this, right? We are turning the screw like this, so the screw is entering in the wall. So the screw direction is the current direction. Screw direction is the current direction. The thumb is moving. For consider here, so screw is entering here the wall. The thumb is rotating. That's the right hand. We are rotating the screw. Okay. So the thumb is moving from my end to your side. So the thumb moving from here to here. here to here. Okay, so the thumb shows the direction of the magnetic field and the screw direction is the current direction. Just remove the screw, there also it is applicable. While removing the screw direction in the opposite direction, that is a current direction, that means this direction, and the thumb finger is moving from your side to my side while releasing the screw. So likewise we can understand what is the direction of the current as well as the direction of the magnetic field by using the corkscrew law. Likewise, the right hand thumb rule. The right hand thumb rule, Fleming right hand rule, that is a different. Fleming right hand rule, that is a generator rule. Fleming left hand rule is the motor rule, but this is the right hand thumb rule. The right hand thumb rule means you consider the current carrying conductor. This is a current carrying conductor, so we can consider the current flowing from bottom to top. That is a current flow direction. Now you connect the right hand thumb with the like a current direction. Okay, so the current flowing from bottom to top. Okay, that is a current direction. Close all the fingers like this. You can see that image also. So here the thumb indicate the direction of the current and the closed, the wrapped fingers shows the direction of the magnetic field. Okay, so by these two laws, corkscrew law and the right hand thumb rule, we can easily remember the current direction as well as the magnetic field direction when current flowing in the current carrying conductor. So these are the combination of the both the right hand thumb rule as well as the corkscrew law. By using this magnetic effect of electric current, what are the applications we are utilizing the day-to-day life? So the first one is the electric bill. The electric bill is working based on the magnetic effect of electric current. Likewise, the electric fan, the loudspeaker, as well as the electric motor, the magnetic crane. The magnetic crane, like so there will be some metal. So when we are passing that current through that, the electric lines is there. Okay, so when the current flowing, temporarily that will be acted as a strong magnet. That will be collected the all iron content, whatever is there, as a wastage. So we can, that will be taken it out and put it in somewhere else. Where we are going to just place it, that time we will release the flow of current. So there will be no magnetic field. So due to the low magnetic field, the iron particles or iron wastage, whatever, that will be filled out. Okay, so likewise the MRI scan also we are using the magnetic effect of electric current. Then finally transformer. This few I'm just listed out here. The transformer, while we are passing the current in the first primary circuit, what will happen? The magnetic field will be created. The magnetic field through the core that will be linked with the next coil, that is a secondary coil. Due to that only we are getting the EMF in the secondary coil. So based on that only the transformer is working. Okay, that is a mutual inductance. We are passing the current here, magnetic field created, that will be linked with the adjacent coil, there the EMF will be generated. Likewise, the day-to-day life we are using various applications in this magnetic effect of electric current. So the next class, some other topic we will discuss. Thank you.